The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and welcome to today's webinar. My name is John Wozniak. I manage QA across PSD's utility rebate programs, and I also manage the PICO New Homes Rebate Program. So I'm going to do some quick housekeeping, if you don't mind. Today's webinar is brought to you by the PICO New Homes Rebate Program. If you can see on my screen here, piconewhomes.com. Again, that's piconewhomes.com. And on the upper right is my phone number if you want to reach out to me. And you can see these tabs here. If you hover over builders, you can see the incentive structure for the program. And down here, you can see that if you're doing an Energy Star home, you can qualify for up to $4,500. So if you were to factor the $2,500 tax credit with that, you're looking at $7,000 potentially. And Dean and Asa are going to go over this, but in order to participate, you need a guide, and that would be a rater. So on this, if you hover on builders, you can see find participating raters. And so these are going to be the raters that are, applied to the program, the PICO program that you can reach out to, and they can walk you through the entire process from, breaking ground until submitting it to programs or for the tax credit. So again, that's piconewhomes.com, and this information will be sent out in a follow-up email. It'll have my contact information. We'll have the Energy Star contact information to reach out to those folks. And we'll also have a PDF of the PowerPoint, and then we'll send up a follow-up email with the recorded version of this webinar. And also, if you're not in the PICO operating territory, there are other rebate programs across the state of Pennsylvania. You can reach out to your program manager if you know who they are. If not, you can reach out to me and I can steer you towards them. Let's see, what else do we got? So yeah, there will be time at the end for Q&A. It looks like the webinar is going to be about 40 minutes. So we have an hour and a half blocked off, thanks to the Energy Star folks, the EPA. So please put your questions in as we go along. And so yeah, welcome, Asa Foss and Dean Gamble from the EPA Energy Star team. Thank you so much for putting in the time and effort, to be here with us today. This is 45 L's on everybody's mind, and thank you so much for putting this together. And I am gonna pass the presentation to Dean. So thank you so much for being here, guys. Appreciate it.
Thanks, John. Let me pull this up and see if everyone can see my screen. Is that coming through?
Yep, looks good.
Great. All right, well, hello everyone. Thanks again for taking time to join us today. I know everyone is particularly busy at year end, and so we appreciate you taking time out of your busy schedule to learn a little bit more about Energy Star. And as you heard, we'll be talking about specifically the Energy Star single family new homes program today and how it relates to the new federal tax credits. Lots of people are asking about that. So let's go ahead and dive right in. This is Dean Gamble talking. I'm the technical manager for the Energy Star Single Family New Homes Program. I'll be kicking things off, and then I'll turn it over to my colleague Asa Foss, who's our program development manager. So let me start with telling you what we know about achieving the new federal tax credit via Energy Star, and then we'll dive into more details about what Energy Star actually requires. So you probably have heard, Congress passed the Inflation Reduction Act, which was a surprise to many people, including us actually. And for the first time, it ties the 45L tax credits for energy efficient new homes to Energy Star certification across all sectors. It increases the amount of the credit, and it extends them for the next 10 years. So as a result, we're preparing for a large influx of new and returning partners, perhaps like yourselves, and hopefully a commensurate increase in the number of homes that come in through our program. While a number of implementation details are still being worked out, we'd like to share what we know. So let me start with a high-level overview. The criteria for the 45L tax credit have been completely redefined, and it will now be specifically tied to Energy Star certification starting in 2023 and extending through 2032 for all three new construction sectors: single-family new homes, multifamily new construction, and manufactured new homes. We also know that a higher credit will be available for homes certified to DOE's Zero Energy Ready Homes program, which has Energy Star certification as a prerequisite. Another important feature of the tax credit is that the requirements are tied to the date when the home or dwelling unit is acquired, whereas our program requirements are tied to when a home or unit is permitted. So our program uses the permit date for a home or apartment because we know that provides certainty to builders. However, the IRS thinks in terms of tax years, and so 45L has long used the acquisition date of a home to determine the requirements, which we informally understand to mean the date that a home is sold or leased. And while we certainly will continue to keep our partners up to date with any new information that we learn about the tax credit, it's the IRS that's responsible for issuing formal guidance on its implementation. To date, we've worked with the Department of Energy to submit a number of questions we have regarding things like implementation dates and program versions, and IRS has actually requested public comment on implementation issues through November 4th, or tomorrow. So you can learn more about how to submit comments if you're interested in questions by visiting regulations.gov and searching for the phrase that's shown on the slide. With that said, here are the main points that partners need to know. Single-family new homes that earn Energy Star certification are eligible for a tax credit of $2,500. From January of next year through the end of 2024, the requirement is tied to certification to the National 3.1 program requirements or the regional program requirements that are applicable to any home or applicable to a home. And then, beginning in January 2025, the requirements scale up to National Version 3.2 program requirements, regardless of whether that version has been implemented by us in the state in which the home is being built. Like I said, we'll talk more about what these versions require in just a minute. Just remember version 3.1 until 2025, and then version 3.2 after that. One important point for partners to understand is that the requirements for earning Energy Star certification in the single-family new homes and multifamily new construction programs in a particular state might differ from the requirements to earn the 45L tax credit. So let me run through two hypothetical examples to explain this. Let's say that a home is built in 2026 in a state that's adopted the 2021 IECC code. We plan to implement National Version 3.2 of our program in states with this more stringent code, so National 3.2 would be required just to certify the home. And because the home is being acquired after 2025, National 3.2 would also be required for the home to earn the tax credit. So that's pretty straightforward. However, in our second example, a home is also being built in 2026, but this time in a state that has no statewide code. Because of the less stringent code, we'd only require National Version 3.1 for the home to be certified. In this case, however, National 3.2 is still required for the home to earn the 45L tax credit, not version 3.1, because it's being acquired after 2025. So in this case, the builder could just build the 3.1 and earn the label on the house, the Energy Star label, and they could be done. Or they could choose to step up to version 3.2 and earn the tax credit. Well, we're primarily here to talk about single-family new homes. Let me just briefly touch on the other sectors in case you're involved with those. For multifamily new construction, dwelling units that achieve Energy Star certification are eligible for a tax credit of $2,500. However, this is reduced to $500 per unit if prevailing wage requirements are not met. As with the single-family program, the requirements are designed to increase in stringency over time as we develop new program versions. However, the language is a little bit less explicit in the legislation, and so we're seeking clarification from the IRS on some of the finer details of how this will be implemented in practice. For those who are unfamiliar with our multifamily new construction program, its requirements are designed to scale with the features of the building. So for example, a low-rise wood frame building without central HVAC systems will have requirements that are very similar to the single-family new homes program. But a high-rise concrete or steel building with a central HVAC system and water heating system will be more complex to certify. The point is that the multifamily new construction program handles buildings across the entire spectrum of the sector. It's also worth noting that, like the single-family new homes program, the multifamily new construction program requires independent verification that our requirements have been met. However, this has historically been a little bit less common in the multifamily sector, things like measuring duct leakage and infiltration, and ventilation airflows, commissioning HVAC systems. So certification might require some extra planning and coordination than what project teams are used to. Finally, let's touch on the manufactured home sector. These are homes that are built in the factory that are governed by the HUD code rather than site-built codes. New manufactured homes achieving Energy Star certification can qualify for the $2,500 tax credit. Again, homes have to meet the most recent version of the Energy Star program requirements. The current version for manufactured homes is version 2. However, version 2.1 was recently proposed in response to the new federal conservation standards by DOE that are significantly more stringent than the prior code. The cornerstone of the proposal is a consistent, well-insulated envelope that outperforms the most stringent code insulation and window requirements by at least 25% for single-section homes and 5% for multi-section homes. In addition, the multi-section homes have to choose one equipment upgrade package, an electric heat pump, a high-efficiency gas water heater and gas furnace, or a heat pump water heater package. And we're currently reviewing stakeholder feedback, and we hope to finalize this new version by the end of the year. Okay, so in the prior slides, we talked about how the tax credit is tied to National Version 3.1 and 3.2 for the single-family new home sector, depending on the year. That might be making you wonder exactly what's required to meet these versions, and that's what we'd like to talk about next. If you're unfamiliar with our requirements for single-family new homes, we can boil down the key components onto a single slide. Most of Energy Star is just a good energy rating, and by that we mean a decent ERI score, grade 1 insulation installation, and now grade 1 or grade 2 HVAC installation. The last step is to include 7 building science-based features to help ensure you don't sacrifice things like durability and comfort and indoor air quality in pursuit of that performance target. There are 2 added comfort features, a complete thermal enclosure system and comfort balanced bedrooms. There are 4 indoor air quality features, a whole house fresh air system, kitchen and bath fans that work well, a MERV 6 or better filter that's properly installed, and combustion safety, and a set of durability details in the form of a complete water management system, meaning things like proper flashing and drainage. So we're talking about protecting the home from bulk moisture. This is not related to low flow fixtures or water conservation. So these are the essential features of any Energy Star certified single family home. And there are actually only 2 differences between National Version 3.1 and version 3.2. The first is the Energy Star ERI target that you have to meet. For National 3.1, it's designed to be at least 10% better than the 2012, 2015, and 2018 ICC, in the range of 55 to 65. For National 3.2, it's designed to be at least 10% better than the 2021 ICC and is in the range of 50 to 55. The second key difference, is a thermal backstop. Sorry, I'm fighting off a bit of a cold, so I'm taking breaks here. Cough on mute. For National 3.1, the home generally must not have insulation and window performance that's worse than the 2009 ICC. And for National 3.2, the backstop is notably more stringent. The insulation and window performance must not be worse than the 2021 ICC, though a less stringent backstop is allowed for homes that are permitted before January of 2025. So let me walk through these key components in a bit more detail.
Hey, Dean, do you want me to take over if you're struggling?
I'm still doing all right, but I might pass it off to you in just a minute, Asa.
Okay, yeah, just let me know.
Thanks. It all starts with just doing a good energy rating. Simply put, you don't know what you don't inspect. By some estimates, more than 80 individuals representing over 24 trades will touch a home during its construction. Site supers have a lot to keep track of, and they're not always going to be able to have the bandwidth to look at every durability and efficiency detail. And it certainly won't be the code inspector who's paying attention to all this. That's where an energy rater comes in. It's a critical extra set of eyes that should reduce the liability of a builder by keeping tabs on these sorts of details. In addition to visual inspections, it's the rater who has the equipment and the expertise to measure key features like infiltration, duct leakage, ventilation airflow, and installed HVAC performance. So this is an easy but critical first step. Every builder can and should be doing an energy rating, otherwise you're just flying blind. Fortunately, we know that a lot of builders have taken this first step. ResNet reported that close to 300,000 homes were rated in 2020 alone, and that number has only increased since then. Now we've got another 700,000 or so homes to go. But what this means is that 300,000 homes are already meeting this first requirement to reach certification just by doing an energy rating. Now, an energy rating is just an assessment. So while it's a critical first step, it doesn't mean the home is good. A terrible home can get an energy rating, so it might get a score of 130. That's better than not knowing that it's 130, but it doesn't make for a good home. A good energy rating means a decent ERI score. And that's why Energy Star defines an ERI target. And like I said earlier, aiming for something in the range of 50 to 65 will get you to Energy Star in almost every state in the country. And the average ERI of all rated homes last year was 58, squarely in that range. That means of those 300,000 rated homes, on average, more than half of them, or 150,000 or so, are probably already meeting the ERI target that's required for Energy Star certification. What sort of measures allow you to hit the Energy Star ERI target? Well, a good place to start is by looking at the Energy Star reference design. These are the features that are used to set the target for each individual home. If you use all these features in your home, then by definition, you'll be pretty close to hitting the target. Remember though, if you see something here that you don't like, you can use other efficiency features instead, as long as you hit the target. So let's walk through the key features of the Energy Star reference design for version 3.1 and version 3.2 for the 3 climate zones in Pennsylvania. The cells in bright blue are those that have changed between the 2 versions. So let's start with the enclosure. For National 3.1, the insulation is aligned with the 2012 IACC. For National 3.2, it's aligned with the 2021 IACC. The windows and doors are aligned with the latest Energy Star spec for windows and doors at the time that we created these versions, and the infiltration rate is 3 ACH50 across the board. For the HVAC system, there's an increase in air conditioner efficiency with version 3.2 and some refinements to the heating equipment efficiency, both furnaces and heat pumps. These were generally aligned with the latest Energy Star product specification at the time the 2 versions were developed. And the equipment is paired with ducts that are in conditioned space and a programmable thermostat as well. And finally, we have the water heater, which goes from a storage water heater in version 3.1 to either an instant gas water heater or a heat pump water heater in 3.2, plus Energy Star refrigerators and dishwashers, and an upgrade from 90% CFL lighting to 100% LED lighting in 3.2. Now, I know that's a lot to take in, but just glancing at these specs might start to give you an idea of how close you are to hitting our performance targets. And remember, for the tax credit, version 3.1 is generally required until 2025, and version 3.2 is going to be required for 2025 and beyond. Now, Standard 301, the standard for doing energy ratings, already has mechanisms to assess more than just the score alone, such as insulation, installation grades. So to us, a good energy rating also means achieving grade 1 insulation installation. This helps a builder get the R value that they paid for, and it reduces the chance of comfort complaints. If you're paying for, say, an R15 high density bat, then you should be expecting that your installers are actually delivering R15 performance, not installing it so poorly that you're getting something like R13 instead. So that's really important. And now HVAC grading helps a builder ensure that their heating and cooling systems were properly designed and installed. A grade of 1 means that the system was installed really well. A grade of 2 means it was installed okay, so not great, but not terrible. And this really shouldn't be taken for granted. Studies have shown that there's improper airflow in nearly 50% of systems, and incorrect charge in 60 to 80% of systems. So unfortunately, you can't just assume that everything is okay. You need to check. Now, why should you care if airflow and charge are correct? Well, the first reason is that HVAC installation impacts efficiency. So consider a builder who's paid for a 16-SEER air conditioner. The SEER rating, which is based on a standard lab test, is never going to change. But the installation quality will impact the on-site performance of the equipment. A properly installed system will maintain that rated efficiency, meaning the home will get 16-SEER performance, whereas a poorly installed system will degrade that rated performance. The system is still rated 16-SEER, but the actual field performance might be closer to that of a 14-SEER system. So what does that mean? It means more energy and higher bills than what the builder paid for. And that's not even the worst part, because HVAC installation also impacts capacity. That means the amount of cooling or heating that a system can produce. In other words, the 3-ton system they paid for should actually deliver 3 tons of cooling capacity rather than 2.8 or 2.9 from a poorly installed system. Now, a small change in capacity might not seem like a big deal, but tell that to the homeowner who calls you on the hottest summer day when you need every last bit of cooling power that was promised. So efficiency is great, but eliminating a comfort complaint or managing humidity better, that's priceless. It's because of these common installation defects and the impact that they have on performance that we help spearhead the development of something called Standard 310, a standard for grading the installation quality of HVAC systems. And as you may know, there are 5 key tasks in this new HVAC grading standard. They include a design review, a total duct leakage test, a measurement of blower fan airflow and blower fan watt draw, and an assessment of refrigerant charge. Doing these 5 tasks gives you a wealth of information about the HVAC system that can help save energy and reduce your risk as a builder or developer. But on top of that, HVAC grading makes it easier to certify ENERGY STAR homes and apartments in 4 key ways. First, it integrates most of our ENERGY STAR HVAC requirements directly into a good energy rating. So there's less stuff that you have to do specifically for ENERGY STAR. Second, and this is a big one, for systems that are eligible to be graded, it doesn't require the use of a credentialed HVAC contractor, which has been a sticking point for some of our partners in the past. Third, this also means that it eliminates the completion of the HVAC commissioning checklist. And finally, it rewards proper installation with ERI points, so that can help you meet the 45L tax credit. So within ENERGY STAR now, we have 2 tracks for completing the HVAC design and installation requirements. There's what we call Track A, HVAC Grading, which uses this new standard. And there's our old requirements called Track B, the HVAC Credential Track, and that relies on the use of a credentialed HVAC contractor. Let me just compare these 2 tracks side by side. So first, the HVAC designer completes their design report. For the HVAC grading track, they'll complete a standard 310 design report with an ENERGY STAR supplement. Well, for Track B, they'll complete the old ENERGY STAR HVAC design report. Either way, the designer is filling out design documentation. In both cases, the rater is going to complete the rater design review checklist, but in Track A, they'll do a comparison primarily using the standard 310. Well, in Track B, they'll do the design review just according to our ENERGY STAR specific requirements. Also, just in Track B, the rater will have to verify that the contractor is credentialed, because that's a key part of that track. Now let's move into the field. The HVAC contractor will install the equipment in Track A. In Track B, they'll do the same, but then they'll also complete the ENERGY STAR HVAC commissioning checklist. Again, that's just required for Track B. For the rater, in both cases, they'll complete the rater field checklist. In Track A, they'll complete the total duct leakage test and 3 new field tasks, and they'll have to get certain grades. In Track B, they're going to verify total duct leakage limits as well, but then they'll measure the static pressure, and they'll have the option of collecting the HVAC commissioning checklist. Now, you can use either track to certify ENERGY STAR homes, but as we've been discussing, Track A integrates most all of these requirements directly into an energy rating. Okay, so once you have achieved a good energy rating, a good ERI score, grade 1 insulation, and grade 1 or 2 HVAC. What does Energy Star add to this? Let me turn it over to Asa to answer that question.
All right, thanks, Dean. The last step is to include 7 building science-based features that help ensure that you don't sacrifice durability, comfort, or indoor air quality in pursuit of that ERI target. And chances are you are already doing some items on the list, so it really shouldn't be 7 fully new items. But including the full set of 7 features will help ensure you have a well-rounded, high-performance home. So in other words, don't let your home skip leg day. If you take a home with an ERI of 130 and slap some PV on it, you can get a good ERI score, but that's not a well-rounded home. So real quick, before we walk through the 7 features, let's play Mythbusters here and talk about what is not required, despite some common misconceptions. Energy Star allows ducts in the attic. That's a tradable feature in the energy model. Same thing with the infiltration. There is no strict limit, it's tradable. Energy Star certified bath fans are not required in every bathroom, only when a fan is used as a whole house fresh air system. And while Energy Star does require insulation along the attic perimeter, the level is generally achievable without a raised heel truss. You can check out the tech bulletin on our website for full details. But the takeaway is that if any of these items were holding you up, we've got some great news. Here's what actually is required, and let's start with an easy one. Each Energy Star certified home and apartment includes a MERV 6 filter or better in the heating and cooling system, which is going to remove contaminants from the air as it passes through. Okay, hopefully pretty straightforward. Next is a durability feature, the water management system, which basically means proper flashing to keep bulk moisture draining away from the home. In other words, don't tuck your raincoat into your underwear. Originally, years ago, this was a builder checklist, but at this point, we've completely eliminated the checklist and paperwork collection. It's simply a list of details for the builder to implement. And almost all of this is now baked into code. So it's not really asking even for anything additional on paper. But we know it's super important for high performance homes because leaks and other moisture issues can be so damaging. And in fact, many of our partners go above and beyond these requirements already, for example, by having third-party assessments. Feature number 3 is combustion safety, which comes in a few different flavors. Either power vented or direct vent appliances, combustion safety testing, or keeping the combustion appliances outside the home's pressure boundary, or just use the electric appliances that avoid the combustion issues altogether. Whichever strategy you choose, this is really just a question of due diligence to keep home buyers safe. So let's pause. These first 3 features should be pretty much gimmies that you're already doing, but Energy Star is just double checking because they are just so important. Let's now move on to something that might be a little bit more of a learning curve, the complete thermal enclosure system. You're almost there just by doing a good energy rating. You'll just need to do a few more things. We'll make sure there's enough insulation and windows to prevent problems. This is where the thermal backstop comes in, which is more stringent for version 3.2 than version 3.1. For example, look at this infrared photo of a home without slab insulation. Now in Pennsylvania, you might be able to get a good ERI score without slab insulation, but you're going to end up with pretty cold feet. Another part of the enclosure, and you'll already have this if you're doing a good energy rating, is grade 1 insulation. And then we'll make sure the obvious leak points are sealed, like around windows, exterior penetrations, attic hatches, and things like that. There's one other detail of the enclosure that we focus on here, and that's the framing. I know it doesn't sound like that much when it's spread out, but if you picture all those studs collapsed together, a standard wall is about 1/4 wood. You're basically building 75% of an insulated wall and 25% of a log cabin. And wood, of course, is not a great insulator, so that's a lot of area to lose heat through. But with some attention to consistent on-center spacing, 3-stud corners, ladder blocking, and things like that, we can bring that framing fraction down from 23% to about 19%. And that's a huge win, obviously, because that's less framing you'll need to buy. So just to conclude this measure, most of this has been integrated into code by now anyway, but code inspectors don't always look for this stuff. Your energy rater is a real expert here, and they'll help you figure out which of these items might need a little tightening up. Okay, so 3 more to go here. Because we're building a high-performance home, we're going to build it tight and ventilate it right. And that means we'll add a whole house fresh air system to deliver a consistent amount of fresh air into the home. There's a variety of options to do this, from a bath fan with a special control, to a motorized damper on the HVAC system, and all the way up to something like an energy recovery ventilator. But the point is, this system is going to have to control over the air that enters the home, instead of leaving it to the whims of Mother Nature. And this is now required by nearly half of the states anyway, including, I believe, in Pennsylvania. And even where it isn't required, it's really something that you should be doing regardless for the health and comfort of your home buyers and occupants. So that was bringing fresh air in. The other half of the air quality equation is taking the bad air out. And so we'll add vented exhaust fans in the kitchen and all full baths. Did you know that cooking creates contaminants like formaldehyde, ultrafine particles, fine particulate matter, and excessive water vapor? And you can include carbon monoxide and nitrogen dioxide to that list of pollutants if you're putting in a gas range or oven. You're really kicking up a lot of bad stuff into the air. There's a reason commercial kitchens have enormous range hoods with huge rooftop fans. And in the home, range hoods that are installed in recirculation mode just blow these contaminants back in your face. So although recirc hoods may look good, they aren't really doing anything. So we want these range hoods to be installed with ducts that go to the outdoors to get these contaminants out of the home. And then the last feature are bedrooms that are comfort balanced. You know, homeowners spend more time in the bedroom than all other rooms combined. And when bedroom doors are closed, as they often are, air can become trapped. It's not enough to supply conditioned air to each bedroom. That air also needs a path back to the HVAC return side. There's a variety of ways to create a return air pathway, such as a transfer grill, jump ducts, dedicated returns, or not as recommended, but maybe even just as simple as undercut doors. You know, it reminds me of a builder who EPA worked with over the last 10 years who resisted this tooth and nail. They just didn't see the value. And then at some point, their in-house HVAC design team realized that their HVAC systems just couldn't work as expected without the return air path. So they incorporated them into all of their homes nationwide, even when they weren't doing Energy Star. And actually, that same builder had a similar story with kitchen exhaust. They saw a presentation at our partner meeting one year on the latest cooking contaminant research, and it basically scared them straight. And so they've added vented range hoods to all of their homes as well. So to summarize, if you're used to thinking of Energy Star as a stack of checklists, this really should change your perspective. It's really just a good energy rating and 7 essential features. And I say essential because which of these features would you tell your client to leave out? Which would you leave out of your own home? And just how difficult and expensive would it be to add these features at the time of construction? So now that you know what is required, let's cover how to get started. If you want to view the full program requirements, you can do so by visiting energystar.gov/new homes requirements. You can also learn more by viewing the recent webinars in our Energy Star Residential New Construction webinar series, which concluded just a few weeks ago. You'll find those by going to energystar.gov/new homes webinars and clicking on recordings of Energy Star webinars. And beyond that, perhaps the most important steps for builders and developers is to find a rater so they can analyze how close your plans are to meeting Energy Star. They really are critical to helping you guide through the certification process. On our partner locator, you will find a list of qualifying raters who are eligible to certify homes and apartments to Energy Star. Once you've done that, you'll need to review and sign EPA's free partnership agreement to make you eligible to certify your homes. So now, while I still have your rapt attention, I also want to take this opportunity to introduce a new certification program for our team. In order to address the challenge of climate change, we now know that residential new construction must reduce operational emissions. This requires the home building industry to expand beyond increasing energy efficiency in homes to make more significant strides in the adoption of strategic electrification, connected equipment to aid in demand response, and an expansion of electric vehicle charging capability. The broader context here is that the electricity grid has gotten cleaner and will continue to get cleaner. So our pitch is that this new Energy Star NextGen certification program is what the next generation of homes is going to need to look like. Our new certification program is not intended to be a replacement for the core Energy Star new construction programs like version 3.1 and 3.2, nor the US Department of Energy's Zero Energy Ready Homes program. Rather, it will work in conjunction with these established programs to provide an additional level of recognition for those builders that choose to pursue it to achieve significant emissions reductions. Our goals for the Energy Star NextGen homes and apartment programs are to define the major elements and technologies necessary in new homes and apartments to support operational decarbonization, to recognize builders and developers for incorporating these elements into their homes and apartments with the government-backed label, marketing, and awards, to create a national platform for training, tools, and support to help the industry achieve success with decarbonization technologies, and finally, to provide state and local policymakers, including utilities, with a national standard for efficient home construction, coupled with decarbonization features that can be used as a model for the development of future policies and incentives. The new program will rely on the same energy efficiency levels specified in single-family national version 3.2 or multifamily version 1.2. As a reminder, 45L requires Energy Star version 3.2 for homes acquired starting on January 1st, 2025. So if you're planning on taking advantage of that pot of money, you can pretty much already check that box for highly efficient construction. After starting with efficiency to earn the NextGen label, projects must also meet a set of efficient electric technologies, as well as adding EV charging capability. For each of these technologies, we've developed a couple of straightforward requirements to ensure that they're designed and installed properly. Each measure required in NextGen can all be independently verified by the same home energy raters that currently provide verification for Energy Star homes and apartments. And these requirements will be documented by the rater using a single one-page checklist. One important note that I would like to draw your attention to is that we are not requiring all electric homes or apartments or banning gas. We have framed our requirements around what is present in the homes and apartments, not what is prohibited. And in case you're unfamiliar with why there's so much momentum around heat pumps, it's because these highly efficient technologies for space and water heating are the only realistic way to substantially reduce greenhouse gas emissions in buildings. This graph that I'm showing here compares the emissions of a furnace, shown in orange, with that of a heat pump, shown by the two blue lines. In this table, we're comparing the emissions intensity of an extremely efficient 98% AFUE furnace to the emissions intensity of a moderately efficient heat pump with an average annual COP of 2.5. A COP of 2.5 is roughly equivalent to an HSPF of 8.5. The y-axis is showing pounds of CO2 equivalent per kBTU of heat delivered by the equipment. So the orange line at the top is natural gas emissions, accounting for both upstream and downstream emissions. The historical emissions are from eGrid, shown in the dark blue line at the left, using average annual emissions from the national electric grid. And the projected national average emissions are in light blue, taken from a DOE tool called Cambium. The gist is that this is a middle of the road prediction of future electricity emissions. So what do we see? Natural gas emissions don't change over time. On the other hand, electricity is projected to continue to get significantly cleaner over the coming years. And in case you're wondering, doing the same analysis for heat pump water heaters will yield nearly identical results. So this is a blunt demonstration, but hopefully it helps answer any lingering doubts you have as to why Energy Star NextGen is so all in on heat pumps. So what can builders do to prepare for when the program launches in 2023? First, you can start by reviewing the program requirements that we finalized earlier this year. You can find them at energystar.gov/nextgenhomes, or on the main program requirements page on the Energy Star website. They currently reside in the one-page radar field checklist that I referred to earlier. Dean mentioned that we've released some webinars recently. Well, one of them covers Energy Star NextGen. You can review that presentation if you want to get into the weeds a bit more. And I'd like to end by reinforcing that this is a new Energy Star label. It does not replace the core Energy Star program that has been around for 25 years and which are now called out in the 45L tax credit. Our intent is to provide a national platform where builders, product manufacturers, utility, and policymakers can all come together to promote a pragmatic approach to achieve these significant operational emissions reductions. Finally, here's some helpful links and our contact info. And now we can open it up to see if any questions have come in.
Yep. So great stuff, Dean and Asa. Thank you so much. Folks, there's a link to the PDF in the GoToWebinar tab, just to make you aware. So it's the first question. Are raters required to check the refrigerant charge for V 3.1 and 3.2?
Great question. So there are two options as we were talking about, track A and track B. So track B, which is relying on the credentialed HVAC contractor, means that they're taking care of all of the commissioning verification. So the rater is not involved in any way with assessing refrigerant charge. Under track A, the one that's built on the HVAC grading standard, they do an assessment of refrigerant charge, but it's completely non-invasive. That means they don't have to have a refrigerant license. They're not connecting any gauges directly to the refrigerant line. And the standard has been structured that way, so there's no like pointing fingers saying like a contractor saying it was properly charged until the rater came in and connected their gauges and they messed it up. So under track A, there is an assessment of refrigerant charge, but it's non-invasive. And it's, partners can basically choose whichever track they want to choose to check that box.
Great. So I know our provider group, Cindy Zeiss, heads that up. She's been focusing on the SEER 2, and that's upcoming and what that means. Have you folks been looking at the impact on what SEER 2 would mean?
Yeah, for the Energy Star program, it will have very little impact. We have, as we were discussing, the performance target is defined for each home as an ERI target. So this home has to get 55, that home has to get 56. That's based on those Energy Star reference design configurations, and those will remain exactly the same. So even though SEER 2 and HSPF2 equipment has come out, the reference design itself is going to remain unchanged, and those targets are not going to change. So what that means is your target's not changing. You're now putting in equipment that's rated with these new metrics. What ResNet is doing in the background is developing some conversion factors that will allow raters or the software, the rating software that they're using, to convert the SEER 2 and HSPF2 values back to an equivalent SEER or HSPF value, which tends to be a little bit higher, closer to the original, HSPF or SEER values. So every particular piece of equipment has a slightly different mapping between SEER 2 and HSPF and HSPF2, but these generic conversions that ResNet's providing are going to generally get the performance back to where it was prior to these new metrics coming out. So hopefully that's a long answer, but I think the short version is it shouldn't have a huge impact on you meeting our certification.
Great. You might want to take some notes on this question. Can you please clarify the ERE that is being referenced here? Is it the HERS index or the IECC ERI? I don't think this is always intuitive, since many raters are performing ratings for code, and they can greatly differ depending on design variables.
Yeah, that's a great question. So we're referencing the ANSI standard version of 301, so the one that hasn't been modified by code to change things like ventilation rates and everything. So kind of for all intents and purposes, the ERI that we're talking about is one that's very consistent with how HERS is calculated. So if you're used to seeing HERS scores for ResNet, because that's your home certification organization, in a sense, those are kind of interchangeable with the ERIs that we're talking about. The reason we use the word ERI instead of HERS is because HERS is a proprietary term that ResNet has control over, and so not everyone is allowed to use that. It's like a trademark, basically. So ERI is a generic industry standard reference, and that's what we're pointing to, so that other home certification organizations, for example, can talk about how to calculate our target scores. So think less about the code ERI. That is very different. They made some tweaks that are not part of the ANSI standard. Think more like a HERS rating or the ANSI standard version of 301.
Okay, and then this was an earlier question. How is the date verified? And I'm not.
So for our program, I think I know what the question is. I'll just say for our program, permit date is what is triggering the required version, and that's determined by the rater. Typically, they know when the permit was pulled for that particular house. For the tax credit, I was mentioning that the term reference is acquired, the acquisition date. Again, our informal understanding is when it's sold or leased, and so we'll be looking to the IRS to issue guidance on how that should be demonstrated. I will say that the old incarnation of 45L, the one that existed prior to 2023, had that same term in it. It had the acquisition date was necessary. So it's not like a new term with regards to the tax credit, but it is something that people are asking about how to demonstrate compliance with. And so when IRS issues clarifications on how to do that, we'll share that with our partners. I would guess it'd be something like a sales contract or closing documents, that kind of thing.
Okay, great. And then, so, sorry, it just jumped on me. All right, so there is a comment here. Multifamily new construction does not have flexibility for infiltration. It is saying that 0.30 CFM 50 per square feet of enclosure.
Yeah, we are more focused on single family new homes for this webinar. Maybe we can do another one some other day for multifamily new construction. But one of the mandatory requirements in multifamily new construction is a compartmentalization limit. And so you want to make sure that you're not having air, a lot of air migrate between one unit and the next unit for pest control, odor control, air quality control, and comfort. So that is a requirement in multifamily new construction. Asa, I don't know if you want to touch on that limit, because I know we were talking about that recently in terms of what sort of measures are required to hit something like what's in the multifamily new construction program.
Yeah, so like Dean mentioned, we do have a hard and fast compartmentalization limit requirement in the multifamily new construction. It's 0.30. It is roughly equivalent to about 7 air changes per hour, if you're more familiar with that on the single family side. However, unlike ACH, which has a benefit to larger spaces or larger homes, this CFM 50 per square foot of enclosure area does a better job of being more appropriate for smaller homes and smaller units. In terms of stringency, what we've seen is that to hit this 0.30 target, merely paying attention to like your major penetrations in your envelope, including party walls and shared walls, you should be able to achieve the 0.30. So that means sealing around your plumbing penetrations, paying special attention to your mechanical room, potentially doing a bead of caulk underneath your drywall. If you want to go substantially below 0.30, and there's a lot of good reasons to do that, that's when you'll have to pay more attention to your design details and really, pay attention to where your air barrier is going to be. So again, like long story short, 0.30 is pretty achievable, and if you don't hit it on your first try, you should be able to get it. That was weird.
Not sure what happened there.
Oh.
So
anyway, yeah.
Sorry.
Yeah, so 0.30 is pretty achievable, and if you don't hit it on your first try, just with some field air sealing, you should be able to do that in a non-intrusive way and hit that target.
Great. In 45L, what is the meaning of basis?
I am not sure what where that word is being referenced from.
Andy, do you want to follow up on that? Maybe throw something in the chat, and we can circle back.
I think it's referring to like the tax basis, which is something that is a bigger deal for some affordable housing projects. I think this is a good time to reiterate that we are not experts on 45L. We're experts in our program, and we're working in conjunction with the IRS and DOE, to get the most detailed guidance on program requirements and versions done. For all of the questions that you have on how to actually take advantage of the tax credit on your own taxes or your client's taxes, those are going to be more questions for the IRS directly and your tax accountant. But as we get general guidance on some of those matters as well, we are committed to posting that.
Okay, yeah, and there's another specific 45L tax credit question here that we can follow up outside of this webinar. Are there any other questions that were not answered? Asa, it looks like you went in and answered them as we went.
I did a few. Yeah, I still see the 45L will follow the NSTAR guidelines regarding building height. Since historically the IRS definition has been buildings 3 stories or lower. So our read on the language is that yes, indeed, for projects that are eligible to participate in the Energy Star multifamily new construction program, that they will be eligible for the 45L tax credit. And the multifamily new construction program is for multifamily buildings of any height. That is our read on it. Because as the commenter pointed out that historically 45L has just been for projects 3 stories or less, this is an area that we're asking for confirmation from IRS on it being true.
Okay, and then we have a long one here. The 2012/2021 backstops for 3.1 and 3.2 for windows, doors, insulation, for example, are the minimums, regardless of what the ERA value is, correct? So you may be able to meet the ERA with values that are not meeting the minimums, but that would still conform to the, let me just scroll down here, for the E asterisk or code correct. Energy Star, I guess that's what that's supposed to be. In other words, not able to trade off these or trade these off.
Yeah, that's correctly summarized. So we were saying the 2 key differences between 3.1 and 3.2 are the ERI target and the thermal backstop. The thermal backstop is a mandatory requirement, and so that does mean that you have to meet the backstop defined for those 2 versions in order to certify the home. And so for version 3.1, it's the 2009 IACC. For version 3.2, it's the 2021 IACC. Maybe a point of clarification is that we do allow a UO calculation to be done. And so we allow basically trade-offs between the assembly. You could put in more wall insulation in exchange for more roof insulation, attic insulation. You could put in better windows in exchange for less wall insulation. So you do have some flexibility to move the thermal performance around the enclosure, but you couldn't say, put in an 18-tier air conditioner and reduce the insulation in response to that. For version 3.1, it's really quite achievable. The 2009 IACC is not a very stringent backstop, so I don't think builders are going to have any trouble with that. With version 3.2, the 2021 IACC backstop is definitely more stringent. It varies depending on which climate zone you're in as to how much more stringent it is than the 2009 IACC. We've been sort of counseling builders to, as they start to look at compliance with 3.2, take a close look at your window performance, because that is a huge lever in terms of your overall, thermal enclosure value, basically. So if you can put very good windows in, that allows you to have a lot more flexibility in, say, whether you have to do continuous insulation on the walls. So that's a long answer with a short recommendation, and I'm sure we'll be talking more about that with partners as they start thinking about 3.2 compliance in a year or so.
All right, well, I'm looking and it appears that all of the questions are answered. So you can get a half an hour back. Guys, thank you so much. Dean and Asa, great stuff here. We really appreciate your time here and talking to our folks. All right, thanks everybody. Again, this webinar will be sent out. There's a link in the go-to box for you to download the PDF, and please reach out. Thanks again, guys. Really appreciate it.
Thanks, guys.
Have a good one.
Take care, everybody. Bye.